Hey guys, I'm gonna bust through this review and hopefully help you out. The key is always just figuring out which thing to do because we learned several things. Whenever it says how many, you're just counting, you're not doing probability, can be created using 4 letters followed by 3 digits. So this is that fundamental counting principle. Here it says you can repeat them. So I'm gonna have 1, 2, 3, 4 letters and then 3 digits. There are 26 letters each time, and I can repeat them. So I have 26 choices each time. And then with digits, you can use anything 0 through 9. So you would have 10 options each time. So then it just becomes multiplying those all on your calculator. And then the way that changes here when you can't repeat is you go from having 26 options down to 25, 24, 23. For digits, you have 10 choices, then 9, and then 8. And so it's straight up fundamental counting principle. You're just filling in, like I keep saying, it's kind of like math hangman. You're filling in those spots. Here it's telling us to do permutations, but we are watching for any repeats. This doesn't have any permutations. So there are 4 factorial ways because there's 4 letters. And when I do that on my calculator, that's 24. Meaning if I wrote out 1, 2, 3, 4 spots and filled them with the letters of the word math, I'd have 4 choices, then 3, then 2, then 1. Banana is different because even though there's 1, 2, 3, 4, 5, 6 letters, you have to divide out the fact that there are 3 letters that repeat as A's, and then there's 2 N's, so I have to factor those out as well. And then I do that whole thing, including the parentheses, on my calculator, and I'll get 60. This is straight up calculator, so I go to 8 factorial on my calculator. You got to find some of these buttons or it'll be too tricky to get through the test. This is going to turn into 7 factorial over 3 factorial. And so when I do that on my calculator, I got 840. This is 8p3. Hopefully everybody found how to do that on your calculator. You should get 336. And then 10 choose 2 on your calculator should kick out a 45. So this is 100% about making sure that you know how your calculator works and making that like something you can find. Okay, so we have 10 teams. How many different rankings? 1 to 10. So that's an order. Like how many different ways can they be put into order? Since we're ranking all 10 of them, you would do 10 factorial, or you could do 10 place 10 in order. And whichever way you do that, you get a giant number. I got like 3,628,800. In how many ways can 3 finish first, second, and third? So that's a permutation. You have 10 teams and you're placing 3 of them in first, second, and third place. And that comes out to be 720. Packing for a trip, Dan decides to take 4 sweaters from the 10 he owns. How many ways can he choose his selection? So he has 10 and he's choosing to take 4 of them along. It's not specific placement. It's just which group of 4 sweaters will he take out of the 10 that he has, and that should come out to be 210. Again, 100% calculator. Good idea to write all of these setups onto your test so that I can see what you did in case your answer is wrong. Then I can give you some part credit. Okay, here we have 2 different types of buns, 6 cheeses, 5 meats, 8 vegetables. How many sandwiches can you make if you just choose one of each? So I have 2 types of buns. I have 6 cheeses, 5 meats, and 8 vegetables. So that's, again, the fundamental counting principle, and that comes out to a total product, because you're multiplying those, of 480 different sandwiches. Here, you have 2 kinds of buns, but here you're choosing 3 choices out of the 6 cheeses. So you have 6, choose 3. Now you're going to pick 2 meats from the 5. So that's going to be 5, choose 2. And lastly, you're picking 5 out of the 8 vegetables. So 8, choose 5. Here comes the choking part. And then you're going to multiply those all together. When I do those, 6, choose 3 came out to be 20. 5, choose 2 came out to be 10. And then 8, choose 5 came out to be 56. And then I got to multiply by that 2 that's up front. So I ended up with 22,400 choices in that situation. Okay, this is using cards. So if you're not familiar with cards, go back and use the little green sheet. How many 5-card hands can be dealt? Well, there's 52 cards, and you would be choosing 5, like a group of 5 cards. And that comes out to be 2,598,960. How many of those have 3 hearts and 2 non-hearts? So you have a group, like 2 different categories. So for the hearts, there's 13, and I'm choosing 2. And then for the non-hearts, that's the other 39 cards in the deck that are not hearts. And from those, I'm choosing, this was hearts. So I'm going to choose 3 of those and then 2 of these. So this first grouping is 3 hearts and then 2 non-hearts. And so that came out to be 211,926. Here we switch to probability, not just how many, probability that a single card is a heart. Well, there are 13 hearts out of a total of 52, and you always want to reduce or write it as a decimal, so 1/4 or 0.25. Again, probability that a single card is a face card. So there's 12 out of 52 that are face cards. So I'm just reducing that fraction. I kind of feel like most of you don't do it as fractions, but you could have 3/13, or what did I get as a decimal? 0.2308. Round it off. Okay, probability that a single card is heart, or, okay, I'm going to go down here where I have a little room. Or means probability of the first thing, which is heart, plus the probability of the second, which is face, minus the probability that you're choosing a card that's both. It got counted twice. So 13 out of 52 are hearts. 12 out of 52 are face cards. But 3 cards are both hearts and face cards, so I counted them twice, and they need to be subtracted. And so when I did that for part E, I got 0.4231. Here, probability heart is drawn, replaced, and then another. So it's 2 probabilities. So in the first one, to draw a heart is going to be 13 out of 52. Replacing it means there will still be 13 hearts and there will still be 52 cards. When I multiplied those 2 probabilities together, because there was multiple events, so you multiply, it was an and then the next thing happens, 0.0625. Okay, what is the probability that a heart is drawn, not replaced, and then another heart? So this is a heart followed by a heart. Here we had 13 out of 52 cards that were hearts, but not replaced means that these just became dependent on each other. Now I only have 12 hearts left because you kept one out of 51 cards, and that leaves me with a probability of 0.0588 when I multiply them together. All right, so a jar contains 14 red, 7 green, and 12 blue. So that is a total of 33. So when it says probability of selecting blue, I need the number of blue over the total, because probability compares to the total, and I get 0.36 repeating. Now we're switching to odds. In favor of green means green compared to not green. How many are green? 7. How many are not green? Well, there's 33 total, so if I take out the 7 that are not green, then it's going to turn to 26. And nothing goes into both 7 and 26, so I can't reduce. Here we're doing odds again. Against selecting red means not red, and then second number is going to be red. So the ones that are not red, well, first of all, there's 14 that are red. So I have 33, which means the other ones that are not red would be 19. And again, 19 and 14 don't have anything that can reduce, so it stays as 19 to 14. Now we're back to probability, where we're going to compare to the total. A green and then red without replacement. So probability of green is going to be 7 green out of 33. Then next you're trying to get red. So taking one green one doesn't change the fact that there's still 14 reds left. But now I only have 30, oh, it says with replacement. So I'd still have 33 of the marbles. And when I multiply those together, I got 0.0899. What is the probability of drawing red and then another red and then another red without replacement? So that is going to be, excuse me, this is without replacement. So I have 14 reds out of 33, but I kept a red. So now I have 13 reds out of 32, and I kept that red. So now I only have 12 reds out of 31. So the top number is going down as well as the bottom because I'm trying to get the same thing each time. And when I multiplied those together, I got 0.0667. Okay, so now we're talking about theoretical and experimental. Theoretical, remember, is simply what should happen based on math, and experimental is what actually does happen based on the experiment. So what is the, below are the results of a computer simulation rolling one six-sided cube, known as a die. What's the theoretical probability of rolling a 6? Well, there's only 1 out of 6. So that's 0.16 repeating. What's the theoretical probability of rolling a 3 or 4? So rolling a 3 would be 1 out of 6, but so is rolling a 4. So out of the 6, 2 out of 6 of them are 3 or 4. So that actually turns into a reduced fraction of 1/3 or 0.3 repeating. But experimental means I've used the data. Probability of rolling a 6. So I rolled a 6 7 times out of the 50 times that I rolled that on the computer simulator, which is 0.14. And then here, the experimental probability of getting a 3 or 4, well, I got a 3 13 times and a 4 11 times out of my 50. So that's 24 out of 50. And that turns into, well, I guess you can reduce the fraction and write it as 12 over 25, or you can write it as a decimal. I don't really care which. Okay, so here you have to just use the chart of data. The probability that somebody is a female. Now keep in mind, the total of everything is 1,030. So the probability that somebody is female is the number of females over the total. And so the total number of females is 575 out of the 1030. And if you change that to a decimal, you get 0.5583. Part B says the biology majors. So the total people doing biology is over here. Here's biology, here's females, males, and total. So the total is going to be someone doing biology out of the total. So the total number of biology students is 460, and the total of the whole entire student population that they surveyed is 1030, turns into 0.4466. Here, female and biology means they have to be both. So let me kind of erase what I have going on here. In order to be female and biology, that's only 305 out of our complete total of 1030. And so that turned into 0.2961. Here's the trickier one, because this is or. So I have to do female plus biology minus anybody who does both. So total females is 575. The total in biology is 460, but I have to subtract the overlap, which is the females in biology. So that is that 305. And then that all goes over the total of 1030. So when you do this whole top divided by that bottom, you get 0.7087. What's the probability that somebody is in chemistry? So total of chemistry is 470 out of the 1030, turns into 0.4563 on my calculator. And then again, or. So I need all the males, which is 455. Then I'm going to add the chemistry, which was 470. And then I'm going to subtract the overlap. And the place where those two overlap, if I said, okay, I'm looking at males who do chemistry, they overlap right here or intersect at 260. So those got counted twice and have to be subtracted. And then all over 1030, the total of all the kids. So 0.6456. All right, they plan to have 3 children. List all the possibilities. Okay, so 3 kids, 2 options for each. I should have 8 possible outcomes. I get confused, so I start with like all male, and then I write the total opposite, all female. Then I do 2 male followed by a female, and then I write the total opposite. And then I kind of just keep going and move that 1 female towards the front, but then write the matching pair with the opposite letters. And then now that first one's a female and then 2 males, so I do the opposite, which would be a male and then 2 females. So those are my 1, 2, 3, 4, 5, 6, 7, 8 outcomes. What is the probability that all 3 will be girls? That's this, so it's 1 out of 8. The other way I could think of it is there's a 1/2 for each girl, so multiple events multiply, and that turns into 1/8, because 2 times 2 times 2 is 8, not 6. Then, hang on. I'm making you wait out the suspense. Hang on. Okay, if they have a 4th child, this one's kind of tricky. It's just asking the probability that it would be a girl. These are independent. Just because you had a girl doesn't mean you can't have any more. And so the probability of having that girl would be 1/2. Or 0.5 if you're using decimals. And then here you would have had 0.125. So none of the math is hard. It's all calculator based. It's just a question of whether you know which thing to do. So make sure your notes are helpful to you because you get to use them. Thanks, guys. Bye.